Hello guys, welcome back to my channel. So I'm making this video because someone in the comment section requested me to perform an integration. So I'm sorry I can't take your name because it was in Russian and definitely I don't speak Russian. So um, let's just call you Anonymous. So Anonymous, this video is because you requested it. Let's get started with it. So I was requested to perform the integral, let's call it I, the indefinite integral of 1 over 1 plus x to the fifth power dx. Well, no upper and lower bounds were mentioned, so I assumed that it was an indefinite integral. Now the first thing that we can do, because all other techniques are gonna fail, the first thing that we can do here is try to somehow split this denominator into simpler factors. Now notice that if you plug x equals negative 1 to the fifth power is going to be negative 1, plus 1 is going to result in 0. So negative 1 is a root of say this polynomial equation. So which means by the remainder factor theorem, x plus 1 is a factor of 1 plus x to the fifth, and this knowledge is sufficient enough to make us find other factors for this thing. So let's do this long division over here. We have 1 plus x, as I just told you, it's a factor of 1 plus x to the fifth, so we're going to divide 1 plus x to the fifth by 1 plus x. So firstly we're going to be multiplying by x to the fourth, so we have x to the fourth plus x times x to the fourth, which is x to the fifth, and then subtract everything. These terms cancel out. We have 1 minus x to the fourth, so we subtract by x cubed, we get negative x cubed, and negative x to the fourth, and then when we subtract, this becomes a plus, so this cancels out. We have 1 plus x to the third power, so we take plus x squared, and we end up with x squared plus x to the third power. Subtract again, we have 1 minus x squared. Now we take negative x, so it's sort of alternating signs, so negative x minus x squared, again minus will make this a plus, these cancel out. We have 1 plus x. Finally 1 plus x will go with the divisor one time, so just add 1, because then you obtain 1 plus x, and then you subtract, so you get rid of this entirely, you get 0. So since there is no remainder over here, we perfectly ended up with a 0. This means 1 plus x to the fifth power can be expressed as 1 plus x times x to the fourth minus x cubed plus x squared minus x plus 1, basically the quotient that we obtained over here. So because of this, our original integral I now becomes dx over, we can write this as the product of these two, so 1 plus x times x to the fourth minus x cubed plus x squared minus x plus 1. So now notice that we have two factors being multiplied with each other in the denominator. So our best bet here going forward is using partial fraction decomposition, so that we can write this as some quantity over the first factor plus some quantity over the second factor. But this partial fraction decomposition is going to be slightly slightly more cumbersome. You'll see in a while. So let's get to the next page. See you there. So forget the integral for now. We had 1 over 1 plus x times x to the fourth minus x cubed plus x squared minus x plus 1. I want to write this as a because we have a linear term as the first factor. So the numerator has to always be a degree less than the denominator. So the denominator has a degree 1 because it's a linear term. So a has to, the upper numerator has to have degree of 0, which is nothing but a constant a. But now using the same logic for the second factor, we have a degree of 4 for the second factor. So we need to have a polynomial of degree 3, basically a cubic polynomial. So this should the cubic polynomial would be written as bx cubed plus cx squared plus dx plus e divided by x to the fourth minus x cubed plus x squared minus x plus 1. So when you cross multiply everything on the right hand side and then you cancel the common denominators from the left and the right, you end up with 1 equals x to the fourth times a plus b plus x cubed times negative a plus b plus c plus x squared times a plus c plus d plus x times negative a plus d plus e plus a plus e as the constant term. So I just have grouped terms with the common degree. And now notice that there is no x to the fourth here, so this should a plus b should equal 0. So a plus b should equal 0, which means b basically equals negative a. So when we plug that into, well, x cubed also should have a coefficient of 0. So this minus a plus b plus c should equal 0. And we know that b equals negative a. So we have negative 2a plus c equals 0. So c is nothing but 2a. Now we have this quadratic x squared term, and again a plus c plus d should equal 0 because there is no x squared term on the left hand side. A plus c plus d should equal 0. But we know that c is equal to 2a, so a plus 2a is 3a plus d equals 0. So d is nothing but negative 3a. Again, coefficients of x should also be 0. So negative a plus d plus e should also equal 0. We know d is negative 3a, so negative 4a plus e equals 0. E is nothing but 4 times of a. But the catch here is a plus e is not equal to 0 in fact, because it's a constant term and we have the constant term equal to 1. So a plus e equal to 1 and e is nothing but 4a. So a plus 4a is 5a equals 1. A equals 1 by 5. So e will naturally be 4 by 5. D will naturally be negative 3 by 5. C will naturally be 2 by 5. And B will naturally be negative 1 by 5. So in our original partial fraction decomposition, we had A here, we had B here, C here, D here, and E was at the end here. So let's make a substitution for A. A is, as I said, 1 over 5. B is negative 1 over 5. C is 2 over 5. D is negative 3 over 5. I hope you can write the x separate. Negative 3 over 5. E is 4/5. So since we have a factor of 1/5, we can write this as 1/5 times 1/1 plus x. We can also remove the 1/5 factor over here as well. We have 1/5 times negative x cubed plus 2x squared minus 3x plus 4 divided by this denominator x to the fourth minus x cubed plus x squared minus x plus 1. Well, we've performed our partial fraction decomposition. Now let's integrate on both sides with respect to x. So this integral of this expression is going to be the integral of these expressions separately, right? So integral of this with respect to x and 1/5 of the integral of this with respect to x. So well, this can be integrated easily. So we have 1/5 times the natural log of 1 plus x. Yes, we have an absolute value because we don't know if this is going to be, the inside part is going to be positive or negative, definitely. So absolute value of 1/x plus, now I'm going to call this integral j, and what is this? What this is I, right? This is just the original integral that we split into factors. So we have also to find j, and after finding j we'll plug everything back in. Let's do that on a fresh page. See you there. So as suggested, j is going to be 1/5 of the integral of negative x cubed plus 2x squared minus 3x plus 4 divided by x to the fourth minus x cubed minus x squared minus x plus 1 dx. And I would like to take, just factorize a negative from the entire denominator. So we have negative 1/5 times integral from, now this will be x cubed minus 2x squared plus 3x minus 4 divided by x to the power 4 minus x cubed minus x squared minus x plus 1 dx. Now one thing we can do to ease the computation of this devastating integral is we can actually, since we have a degree less than, a degree which is 1 less than the degree of the denominator, we can try to match the numerator to be the derivative of the denominator, so that we can directly take the natural log after integration. So to do that, the derivative of the denominator is going to be 4x cubed, right? So there will be a leading 4 term attached with the x cubed. So let's multiply and divide by 4. So we obtain a 4x cubed on top. So if we divide by 4, because we're multiplying 4 on top, we have 1/5 times 1/4, which is negative 1/20, times the integral of 4x cubed minus 8x squared plus 12x minus 16 divided by x to the 4 minus x cubed minus x squared minus x plus 1 dx. So now we obtained our leading term being equal to the first term of the derivative of the denominator, 4x cubed. Can we split negative 8x squared and all the others, so that we can just replicate the derivative of the denominator on top? So let's do that. Negative 1/20 times integral of 4x cubed. I'm going to write negative 8 as negative 3 because we have a 3x squared, right, as the derivative of this term. So negative 3x squared, negative 5x squared, because they have to add up to negative 8, and I want to write my 12 as 14x minus 2x, then minus 2x because of the derivative of negative x squared term, and negative x will have a derivative of negative 1, so I want to split 16 as negative 15 minus 1 divided by x to the 4 minus x cubed minus x squared minus x plus 1 dx. So we have negative 1 over 20 times, let's just scrape out the derivative of the denominator terms from this numerator part. So we have 4x cubed minus 3x squared minus 2x minus 1. So we basically got rid of this term, this term, this term, and this term, divided by x to the 4 minus x cubed minus x squared minus x plus 1 dx, and all the remaining terms. So we have negative 1 over 20 as it is. By the linearity we can split them into two integrals. So we have negative 5x squared plus 14x minus 15 divided by the same denominator, x to the 4 minus x cubed minus x squared minus x plus 1 dx. Now our advantage is we know how to integrate this, right? So if you have a derivative of a function in the numerator divided by the function itself, that's just the natural log of the function when after integration. So we have negative 1 over 20 times the natural log of absolute value of x to the 4 minus x cubed minus x squared minus x plus 1, because its derivative was present in the numerator, minus, and notice the great part about this term. Now initially we started out with a cubic term. We had a maximum degree of 3 x cubed term. We end up with a maximum degree of 2 because of this x squared term. So I would like to just scrape out the negative from all this. We have plus 1 over 20 now times integral from 5x squared minus 14x sorry plus 15 divided by x to the 4 minus x cubed minus x squared minus x plus 1 dx. So our j has significantly reduced in its complexity to be just, well, we just integrated the first part. All we have to do is now integrate this part, and now notice that in order to go further with our integration, the denominator must be under any circumstances split into two other factors so that we can perform another partial fraction decomposition, which is going to be way nastier than the first that we performed. So I don't know, you guys can just use your graphing calculators or something to find the roots, the roots of this thing, or you can just somehow by any methods factorize this biquadratic into a product of two quadratics. But for me, well, I'm not going to write this term. We're going to have 1 over 20 times integral of 5x squared minus 14x plus 15 divided by, and we can split the denominator as follows: x squared plus square root 5 minus 1 by 2x plus 1 multiplied with x squared minus square root 5 plus 1 divided by 2x plus 1, and don't forget this dx here. So we basically have to do partial fraction decomposition on this crazy expression. And since we have a product of two quadratics, when we split this into the sum of two fractions, the numerator terms will always be linear. So we can express this same thing as well, forget the integral for now. We can express this same thing as 5x squared minus 14x plus 15 divided by this denominator. This we can write as, well, let the first linear term be px plus q, because we used our ABCDs now, divided by the first factor, so x squared plus square root of 5 minus 1 divided by 2x plus 1 plus the second linear term, which is going to be, let's call it rx plus s, divided by the second factor, which is x squared minus square root of 5 plus 1 divided by 2x plus 1. So we have to basically find p, q, r and s. So let's do this term first on another page. See you there. One more fact, that say we find these terms, then we'll anyways have to integrate both sides with respect to x. So we'll have to integrate. It will be a sum of two integrals. So in any case, even if we find px plus q, we have to integrate this. So I'm not going to show you all the steps of partial fraction decomposition because they are too nasty for your innocent eyes. So I'm just going to show you, I'm just going to write values of p and q, and then I'm going to perform the integration on this first part. So let's do that. Well, before proceeding, we had this factor of 1 over 20. So this is basically multiplied with 1 over 20, and all of these integrals are multiplied by 1 over 20. So is this. So I'm going to take the 1 over 20 into account as we do the px plus q. So this, after performing the tedious partial fraction decomposition, is 1 over 20 times, well, p is going to be 2 square root of 5 x, we have the x was already there, plus 13 plus 15 root 5 over 2 root 5, and we have a parenthesis here, divided by this other term x squared plus square root of 5 minus 1 by 2x plus 1. And as suggested, we have to integrate both sides with respect to x because we've performed our partial fraction decomposition successfully. So 1 over 20 outside, we can cross multiply. We have 2 root 5 squared and a 2 root 5, which will make it 40 root 5, 1 over 40 root 5, and we have 2 times root 5 squared, so that will be 4 times 5, which is a 20x plus 13 plus 15 root 5 divided by x squared plus square root of 5 minus 1 by 2x plus 1 dx. So now we can do the game of matching the derivatives of the denominator in the numerator. So we basically need to duplicate the derivative of the denominator in the numerator again, like we did for a previous section. So for that we need a 2x, right? So the leading term should be 2x. So we can divide by 10, so that it be 20 by 10 becomes 2. So when we divide by 10, we're going to also have to multiply by 10 to maintain equality. So multiplying and dividing by 10. So let me write a 10 like this. Sorry for being shabby, but okay. So we have a 10, and this will make 1 over 4 root 5. And then since we divided by 10, we have 2x plus 13 plus 15 root 5 by 10 over x squared plus root 5 minus 1 by 2x plus 1 dx. So to truly duplicate the derivative of the denominator, we also need to add root 5 minus 1 over 2 because of the derivative of this term. So we have 1 over 4 root 5 as it is. So we have 2x plus root 5 minus 1 divided by 2 divided by x squared plus root 5 minus 1 divided by 2x plus 1 dx. But since we added this and there was no initial root 5 minus 1 over 2 term, we also have to subtract that from this other part. So that will be another integral plus 1 over 4 root 5 times, we have, when we find a common denominator, we have to multiply this by 5 so that the denominator becomes 10. So factor of 10 in the denominator. So 4 root 5 times 10 is 40 root 5, and we are just going to have, I'm doing the algebra for you. So 10 root 5 plus 18 divided by, and a dx, we have x squared plus root 5 minus 1 divided by 2 x plus 1. So now we successfully duplicated the derivative of the denominator in the numerator. So we can use the natural log formula. So 1 over 4 root 5 times the natural log of absolute value of x squared plus root 5 minus 1 divided by 2x plus 1 plus, well, this is a constant, right? So we can actually bring it out of the integration. So we have 10 root 5 plus 18 divided by 40 root 5 times dx over, let's complete the square here and let's see if we can use some other properties. So we're going to have, completing the square, x plus half of this term, so root 5 minus 1 divided by 4, the whole thing squared, plus we also have to subtract by the square of this term. So 1 minus this term squared is just going to be, this is going to be 10 plus 2 root 5 by 16, but I'm going to use some other properties, so I'm going to write this as the square of this root squared. So well, we have this term, so we have 1 over 4 root 5 times the natural log of x squared plus root 5 minus 1 by 2 x plus 1, and now we can use some inverse tangent property. So we can invert this, so we obtain 10 root 5 plus 18 by 40 root 5 times inverse of this, so square root 16 divided, so square root of 16 is 4 divided by the square root of 10 plus 2 root 5 times the inverse tangent of, we can have a common denominator, 4x plus root 5 minus 1 divided by, well, the 4's will cancel out in the denominator, so we don't need to worry about that. square root of 10 plus 2 root 5. So it's a natural log and basically an inverse tangent uh, function that we have. If you want, you can cancel this out. This will become 10. So that was our px plus q term. Now let's do the other rx plus s term in a similar approach. So we obtain negative, because there was a negative on the r, 1 over 20 times, well, r is just 2 root 5 times x like before, and this time s is 13 minus 15 root 5 by 2 root 5 divided by x squared minus root 5 plus 1 by 2 x plus 1. And since we obtained everything, let's integrate both sides with respect to x. So we have negative 1 by 20 and well, cross multiplication again. So we have 2 root 5 coming out, so 40 root 5 times integral, this is going to be 2 squared, which is 4 times 5, which is 20x plus 13 minus 15 root 5 divided by x squared minus root 5 plus 1 divided by 2x plus 1 dx. So again we have to multiply and divide by 10. So I'll multiply here and divide inside, you know, so that we match the, we can recreate the derivative of the denominator on top. So we have negative 1 over 4 root 5 times, this is going to be integral from 2x plus 13 minus 15 root 5 by 10 because of that, divided by x squared minus root 5 plus 1 by 2 x plus 1 dx. So now we have negative 1 over 4 root 5 times 2x minus, let's subtract this term, so root 5 plus 1 by 2 divided by x squared minus root 5 plus 1 by 2x plus 1 dx. Since we subtracted this, we have to add that with this term. So this is going to be 18 minus 10 root 5 by 10. So that 10 will come down here. 1 over 40 root 5 times integral of 18 minus 10 root 5 divided by this term, which we can actually complete the square here. So x minus root 5 plus 1 by 2, 4 actually, because we're dividing by squared, and we're going to have plus 10 minus 2 root 5 here, minus 2 root 5 by 16, but I'm going to write this as the square of this square root, you know, just to use the formula for the inverse tangent later on. So we have a negative 1 over 4 root 5 times, now we can write this as the natural log of absolute value x squared minus root 5 plus 1 by 2x plus 1 minus we can write this is 18 minus 10 root 5 divided by 40 root 5 times, when you invert this, 4 over square root of 10 minus 2 root 5 times the inverse tangent of, taking a common denominator, we have 4x minus root 5 minus 1 divided by square root of 10 minus 2 root 5. Well, for your pleasure, you may want to cancel out this 4 and 14, make this 10. So putting everything together, now we have I defined as integral of dx over 1 plus x to the fifth. Let's put together all the terms we obtained. So we have 1/5 times the natural log of 1 plus x from our original partial fraction decomposition minus 1 over 20 times the natural log of x to the 4 minus x cubed minus x plus 1 because of our j term. And now let's write the px plus q term. So that was 1 over 4 root 5 times the natural log of x squared plus root 5 minus 1 by 2x plus 1 plus 10 root 5 plus 18 by 10 root 5 times 1 over square root of 10 plus 2 root 5 times the inverse tangent of 4x plus root 5 minus 1 divided by square root of 10 plus 2 root 5 minus, now we have the rx plus s term, so 1 over 4 root 5 times the natural log of x squared minus root 5 plus 1 by 2x plus 1 plus 10 root 5 minus 18 divided by 10 root 5 times 1 over square root of 10 minus 2 root 5 and times inverse tangent of 4x minus root 5 minus 1 divided by square root of 10 minus 2 root 5. And don't forget the most important aspect of all of this, the constant of integration, c, because it was an indefinite integral, right? So there you have it. That's your solution, anonymous, and all my viewers who are watching. If you don't believe me, go ahead and differentiate it and just get back 1 over 1 plus x to the fifth. That's how you can verify. So go ahead and differentiate it. So that's it for this video, guys. I hope you enjoyed it. Please like, share and subscribe. Recommend me to your friends. This video involved a lot of computation and it actually mentally tired me when I was making the notes for this video. So stay in, stay safe. Peace out. Have a great day.